Okay, we are taking first the assignment problems. Now, problem number 1, 2, 3 is already explained in my YouTube videos in part 4 and part 5. In part 5, you have to make a corrections that I have already explained to some students on WhatsApp. So I will send that message in WhatsApp also. You have to make the correction in one problem. You have to see that problem first. Now we are starting on problem number 4. Apart from these 3 problems, this problem number 4 is also explained in our Zoom lectures. No, I am repeating it. I will write down the data of the problem. It is given a line AB of 70 mm long length. So true length is given. So true length I will take 75 mm. Then it is inclined at an angle of 35 degree to VP. So phi is given. So phi equal to 35 degree. And its end point A is 20 mm above HP. So above HP A dash 20 mm. And 10 mm in front of VP. So A above below XY 10 mm. Then draw the projection of line when plan length of line is 50 mm. So plan length is given 50 mm. So this is 5 datas are given. So I will solve this problem. So what I will do, I will first mark XY line. Then I will take projector perpendicular line to this XY. On this perpendicular line to XY projector lines, I will take A dash. This distance is equal to 20, and I will take A in front of VP. A, this distance is equal to 10. Then I have to mark the remaining data. So I will mark phi here. So this angle I will take phi. Phi equal to 35 degree. So I will take this phi equal to 35 degree. Now this phi I have marked, and on this phi I will mark true length. So this will be my true length. So this true length I have marked A B1. True length is marked. This true length equal to 75. I have marked this. Then immediately I will draw a locus from this true length point. So I will draw the locus from this true length point. And now I have to mark the plan length. So I can mark this plan length. I can mark this plan length on the locus. So what I will do, I will mark plan length on the locus. So I will cut plan length on this. So this is my plan length. I have cut it. So this is AB. Plan length is equal to 50 mm. It is given. So I have got the final plan length here. So I will join it after cutting it. So this will be my plan length after cutting it. Now I want in above true length and alpha. So what I will do, I will use a method of map reading. I know that if this true length is projected, and rotate, it is converted into elevation length. But when you project it and rotate, where it will cut? Here. Because after projection, when you rotate it, it should cut somewhere. Either you want a locus here, or either you want a projector lines here, or either you want a alpha line here. So you don't have an alpha line, you don't have a locus line, but you have a projector line. From this B point, you have a projector line. So what I will do, I will drop a projector line from B point. So I will drop a projector line from B point. This is a perpendicular projector. And then I will project this true length. So this is my elevation length here, and this true length, when I projected it, converted elevation length, I have to rotate on the projector line. So this is the projector line. So with this as an compass center and this much as an radius, I will rotate it. It cut here. Okay, so it cut on this projector line. So I will mark this is B dash, and immediately I will draw a locus from this B dash, and now I will join this A dash B dash. So I will get elevation length. So this is my elevation length and this is my alpha angle. Now I want here true length only. So there is one method. Either you can take this true length, cut here, or otherwise you can rotate plan length, because plan length after rotation and projection. So this is my rotation. So this is arrow, and then I will project it. From this I will project it up. It cut on the locus. So this is second arrow, it cut on this locus. So this will be B1 dash, and this I will join. So this will be my true length and this will be my theta angle. So in this way I have completed this problem. Okay, so this is projected, then rotate on the projector line, it cuts, I get B dash, I joined 11 dash, A dash, B dash as elevation length. Then I rotate this plan length and project on the locus drawn from B dash. It cut here, I get B1 dash, that is a true length endpoint. Or otherwise you can take this true length, cut here, you will get the same true length. In this way these problems can be solved. So the problems with a data of true length equal to 75, phi equal to 35, A dash and A equal to 10 and plan length equal to 50, you will get this solution. Okay, so in this way you can solve the problems. Now we will move to the next problems. So we will start with the next problem. Now the next problem is fifth problem, a line PQ of 80 mm long. So line PQ is given. Okay, so line PQ is given. So I will take true length equal to 80 mm and the line is PQ line. So the PQ line, and for PQ line true length is 80 mm and end point P is 15 mm from both HP and VP. So 50 mm both from HP and VP means P dash is 15 mm and P is below 15 mm. So from both plane P is 15 mm and the end Q is 40 mm. So end Q is 40 mm and 50 mm in front of VP. The end Q is 40 mm above HP. So end Q is 40 mm above HP. So above HP 40 mm and 50 mm in front of VP, and Q is 50 mm in front of VP 50. Draw the projection of line to determine the inclination of the line with HP and VP. So 1, 2, 3, 4, 5. 5 data is given. Now what you have to do? You have to mark XY line. Now this P dash and P you can mark. So P dash and P I will mark. So I will take P dash 15 mm. So this is P dash. This distance is 15 and this P. This distance is also 15. Okay, 15 mm distance from both HP and VP. Now you can't mark a projector line for Q dash and Q because the projector distance, location or end projector is not given. So one projector you have fixed, but how many distance it is away from first projector, that projector distance is not given. But what I will do now, I will draw the locus simply first. Locus means the line on which this Q point, Q dash and Q point will lie. So this Q dash is above 40 mm. So from above XY line, I will draw a locus line. This distance is 40. Okay. And in front of VP, from this, I will take another distance. Okay. I will take another distance, this, and I will draw a locus. Now this distance is 50 mm. So the locus of, this is the locus of point B, and this is also a locus of point B. Here it will, you will get B dash and it will be B, okay, whatever may be. Now what you have to do, you have to mark a true length, because true length is given. So this true length you can mark on this locus. So from P dash, Q1 dash is at a distance of 80 mm, because true length is 80 mm. So I will take a distance in the compass 80 mm, and from this I will mark an arc. So it cut on this locus 80 mm. I will mark it as the end point of true length Q1 dash, and I will join this. So this will get theta angle, and this is true length, right? Similarly, I can mark same true length below XY also. So I will take distance in the compass and I will cut from this P here arc. So this is also a true length. This is Q1. So this is the true length I have cut on this locus line. Okay. So on this locus line I have cut, and this angle is phi only. So I have a true length available. Now I want elevation length and plan length. We know that the map reading concept, that is true length is converted into plan length and elevation by projection and rotation. So what I will do, I will project this true length up. So I will project this, I will draw perpendicular line. So this is perpendicular to XY up to this. So this is a projection, and then this as a distance in the compass. Okay, so this is the projection line, and then I will rotate it. It cut here. It cut here, and I will join this, because this is my Q dash point where it cut, and I will join this. So this is my elevation length, and this angle will be alpha, right? So this is already true length we have find out. Now similarly I can project this true length, and I can project this true length down, and then I can rotate it up to the locus. It cut here, so this is Q, and I can join this. So this is my plan length, and this will be my beta, this will be my beta. So in this way I have completed this problem. So what I have done, as per the data given, P dash and P is marked, then Q dash and Q locus is marked 40 and 50. They are not fixed initially, only locus is marked, and then on that locus, taking true length 80 mm, I cut Q1 point, join this is, I get theta. Then with the true length I cut Q1 point here, so I will get Q1 dash here, join true length. I will get Q1 here after cutting, join true length. So I will get theta and phi with true length, and then I project true length, rotate it, I get plan length, project true length, rotate it, I get elevation length. In this way I have completed this problem. So this will be the fifth problem. Then now we will go for the sixth problem and seventh problem. Okay, So we will go for that problem. So again I will mark a data. So what is the problem given? That is, line CD has a point C on HP. So data is given. So line CD has a C point on HP. C is on HP. So if point is on HP, its projection on VP comes on XY. So C dash on XY, because C is on HP, and 60 mm in front of VP. 60 mm in front of VP means down. So C is down 60. Okay. So C is down 60. C dash is on XY. Then Q on HP and 60 mm in front of VP. Okay. Then other end point D is on VP. So the D point is on VP. So if it is D point in the VP, its projection on HP, that is simply D. D is on XY as per the problem, because D is on the VP and 50 mm above the HP. D is 50 mm above HP, means D dash 50 mm above HP. Okay. Line CD measures 80 mm. So true length is given equal to 80 mm. Draw its projection. 1, 2, 3, 4, 5 data is given. So what I will do, I will take XY line, then I will mark C dash on XY. So C dash is on XY, and C 60 mm in front of VP. So I will move 60 mm perpendicular this distance. So this distance, this is 60 mm in front of VP. So this is C only, right? Then D dash and D. So D is on XY, means from this D is on XY, means projected distance must known. But projected distance is not given, so you can't directly mark D here. So for that case, what you will do, you mark a locus. So D dash locus you can mark. D dash locus is 50 mm above the HP. So I will draw, from this I will draw a line, that is locus line. This is locus line and this distance is 50. So on this line D dash will come. So this is the locus of D dash. So this will come somewhere. Now I know that the true length. So from C I will cut on the locus true length. So I will cut this C, this distance I will take in the compass, cut on the locus. I get D1 dash as a true length end point. So I will join this. So this is true length and this angle is theta. Right? Now I know that I have to find out D on XY, plan length point. Now what I will do, I will project this. I will project this because we have the concept, that is, if this is A dash and A, and if this is B1 dash, if this is true length, okay. So what we will do, we will project this true length up to corresponding point of A. Corresponding point of A dash is A. Up to that point you project it, and then you rotate it on the locus of B. Suppose this is locus of B, and you will get this AB. Similarly, I will project this up to the corresponding point of C dash. So I will project it up to the corresponding point of C dash. So up to this it will project it on this line. And then I have to rotate this point, I have to rotate where on the locus. So I have to rotate this point, D point, on the locus of D. So what is the locus of D? Locus of D is on XY. So D is on XY. D on XY. So as D is on XY, I will project this, I will rotate this So from this as a distance center and this as a distance, so I will take down this, okay, and I will rotate this. It cut here on the locus of D, so this will be my final D point, and I will join this. So this is plan length, and this angle is alpha, sorry, this angle is beta. Now you want true length, and true length here and elevation length here, so you can project this. You can directly drop a projector from D. So if you directly draw projector from D, it cut here. So because C dash and D dash, DD dash and CC dash are the projector. So from this projector I will cut, so I will get D dash point, and I join this. And so this is my elevation length, and this angle is alpha. If you want true length here, you can project this elevation length, rotate this elevation length. So you rotate this elevation length, and project up to the locus of D. So where is the locus of D? Is there itself on XY. You project, you rotate and project up to the locus of D. But where is locus of D on XY? So itself D is here. So this will be your D1 point. This will be your D1 point, and you can join this. So this will be your true length, and this will be your phi. So in this way you can complete this problem. So you have projected this true length, and then you shift on the locus of D, rotate it on the locus of D, you will get the D point. Then from the D you drop a projector, it cut on the D dash, you will get the elevation length, and then you rotate this elevation length and project up to the locus of D. It will itself here, you join it, or otherwise you can take this true length and cut here also. Both will be the same. So in this way you can solve these problems. So this will be problem number 6. Okay, so the problem data is, this problem data is given. So the problem data is C is on XY, C is on XY, C dash is on XY means what? C is on HP, and C is in front of VP 60. D is on XY. Why? Because D is on the VP, so its projection on HP, that D is come on XY, and D dash is above 50 mm above the HP, D dash in true length, and we have completed this problem. Okay, so this is the problem. Now we will move to the last problem of this assignment, that is line MN. So we will take this problem, line MN. So we will have, it is given in the problem, line MN. So line MN is there, okay, has a point M, 20 mm above HP. So above HP means M dash 20 mm, and 50 mm in front of VP means M in front of VP 15. The elevation of line MN measures 60 mm. The elevation length is given 60, and the line makes an angle of 35 degree. So the elevation of line MN measures 60 mm length, and the line makes an angle of 35 degree with VP. So phi is given 35 degree and 40 degree with HP. So theta is given 40 degree with HP. Draw its projection. Now in this case you have to first mark the data first. So I will take, this is XY line, okay, and with this I will mark the point. So line, I will drop a projector. So I will mark M dash, this is 20, and then M, this is 50. Then I will mark an angle of theta 40 degree, This is true length inclination, and then phi equal to 35 degree. But true length is not given, so you can't cut true length on this and this. Okay, and elevation length is given 60, but elevation length is given, but how you can mark elevation length? Because if you want to mark elevation length 60, you must know alpha. If you know alpha here, then you can mark elevation length on that, but the alpha is not given. Okay, so only true length inclinations are given. So there is a fundamental that if your two angles theta and phi are constant, fixed, then corresponding alpha and beta are also fixed. Whatever may be the length, you can take alpha and you will get alpha and beta fixed for theta and phi fixed. So what I will do, if your theta and phi are fixed, then alpha and beta are also fixed. This is the fundamental. So for that, whatever the true length you will take. So considering this, I will take one true length. Assume that this is the point. I will take this point as a P1 dash, and I assume this much true length. So same true length I will take here. This is P1. So this true length I will cut here. Don't project this down. This true length separately, whatever the length you have taken, you cut the same true length here. So you will get P1, and then draw locus from that. And then we have this true length and this true length. For this true length, you can find out elevation length and plan length by projection and rotation. So I will project this much true length here, and then I will rotate it. I will get P1 point. I will join this. So what I will get alpha angle, beta angle here, right? Similarly, I will project this. I will project this up to this, and I will rotate it. Project this, rotate it. I will get this point. This is my P1 dash, and this I will get alpha angle. Now this elevation length and this plan length is corresponding this true length and this true length. But our elevation length is given 60, right? This elevation length is given. So this distance I will take in the compass, and on this elevation line I will cut this. Suppose this is my elevation length, whatever I mean. This may comes here also. This may comes because I am drawing without a scale. So suppose this will be the elevation length total on the same line, elevation line. So this is my final N dash point, and then I will draw up a locus, and then I will extend this true length up to this. This is my final N1 dash. So this is my final true length. Right? I will get this much true length. This is true length. Initially it was up to this, then it is extended. Okay, it is extended. Initially it was up to this, then you will get this. Similarly, what I will do now, I will rotate this elevation length, final elevation length, and project it up to the locus. Project it, and this elevation length is converted into the true length, means it should be cut on the true length or on the projector. So true length inclination is already given. So this I will extend, it will cut here. So this is my final N1 point. This is my final true length. And then I will draw up a locus from this. And on this locus I will extend this length. So this will be my final plan length, Mn. sorry mn. So this is my final plan length. So you got it. So what we have done, we have first drawn theta and phi, but on this theta and phi true length is not known to you. So I will take this much true length initially, same true length I have taken here. Okay, so this P1 point and this P1 dash point and P1 point I have taken here, and then I project this true length, and from this I have drawn locus, and on that locus I have rotated, so it is projected up to this and then rotate it up to this locus. अगर आपने ये लोकस नहीं निकाला तो ये पॉइंट नहीं मिलेगा, इसलिए इसमें यहाँ से लोकस निकालना जरूरी है. फिर बाद में इस ट्रू लेंथ को यहाँ तक लेके गए और फिर इसको रोटेट किया, तो यहाँ से लोकस निकालना जरूरी है. तो ये लोकस यहाँ पे कट हुआ, तो मुझे छोटा सा एलिवेशन लेंथ मिला, कॉरेस्पॉन्डिंग ये प्लान लेंथ मिला. अब इसके ऊपर मैं एलिवेशन, फाइनल एलिवेशन ले लिया मैंने, यहाँ से यहाँ तक n1 डैश मिला. आपके इसमें वो नीचे भी आ सकता है, आप ट्रू लेंथ का डिस्टेंस कितना लेते हैं उस पर डिपेंड होता है. तो ये ऊपर आया सपोज n1 डैश. So this elevation length I have taken, mark it, and then I have draw locus, final locus, and up to that final locus I have extended this true length. Similarly, then what I have done, I have rotated this elevation length, projected it up to this inclination, because true length का inclination था, इसको आगे खींचा, जहाँ पे कट हुआ n1 मिला, ये final true length मिली, फिर वहां से मैंने locus डाला, और फिर ये जो मुझे छोटा प्लान लेंथ मिला था उसको एक्सटेंड किया, फाइनल प्लान लेंथ मिला यहाँ पे. इस तरह से ये प्रॉब्लम सॉल्व हुई. So we have solved these all problems. Now you watch the video carefully and repeat the problem. Thank you.